So today we're going to talk about the Rachel test. So in the infinity series, there are several ways that you can test to see if an equation is convergent or divergent when it goes to the infinity. So what is Rachel test? Let's say your category is like an, so the next one will be an plus 1, right? And then we kind of want to know which one is bigger as it goes to the infinity. What does that matter? Because as your infinity series goes to infinity, if the next one is greater, the value will go to infinity, then it will be divergent. But if let's say your previous one is bigger than the next one, that means the value you add is going to be smaller and smaller. So at the end, it actually becomes at the end, it actually converges to certain value because the number doesn't go bigger, which is very simple. How do you know something is bigger or something is smaller? It's very simple. You just divide them together. So let's say we put a sub n plus 1 on the top, and then we put a sub n in the denominator. And when it goes to infinity, when n approaches to infinity, then we want to know this value. So let's assume this value is p. And we can talk about 3 conditions. First of all, when p is greater than 1. So what does p greater than 1 mean? If you want the p value to be greater than 1, then that means your numerator needs to be bigger than the denominator. Big divided by small number. So the value will be more than 1, which means your a sub n plus 1 is greater than a sub n, which will make the equation divergent because this one comes later and this one is the previous one. So it will diverge. Okay. And the second condition will be p is less than 1. So if your value is going to be less than 1, what does that mean? That means your denominator is bigger and your numerator is smaller. So you will get the value less than 1, which means your a sub n is greater than your a sub n plus 1, which we can see here. Your previous category is bigger than your later one, which means the value to be added is going to be smaller and smaller, and it eventually will converge to certain number. So that will converge. But what if p equals to 1? What does that mean? You don't know, so it's inconclusive. So if it is inconclusive, then you will need to use another test to see if this one is convergent or divergent. Okay, now we can use an example to testify we just teach. Okay, sigma from n equals to 1 to the infinity of n to the power of 4 plus 3 times n to the power of 3 plus 2, n to the 2 plus 4 times n plus 5, all over 3 to the power of n. Let's use the Rachel test to see if this series is going to be divergent or convergent as it goes to the infinity. So let's just put the equation here. Limit n approach to infinity of a sub n plus 1 all over a sub n, which will be, I will use different color, n plus 1 to the power of 4 plus 3 n plus 1 to the power of 3 plus 2. I will just write down the coefficient here, so I don't have to change color all the time. So this will be n plus 1, and this will be 2 to the power of 2 and to the power of 1, all over 3 to the power of n plus 1. Okay. Then let's see here. So here is the reciprocal of an. We can just write it down over here. It's 2. There's no space. I make it smaller. So we times the reciprocal of an. So we just simply put the denominator on the top and put the numerator in the bottom. N to the power of 4 plus 3 times n to the power of 3 plus 2 times n to the 2 plus 4 times n plus 5. Okay, and now we can observe and the cancel some of them. As you can see here, 3 to the power of n plus 1 will be 3 to the power of n times 3, which we can cancel here. Okay, so 3 will be left. And then the other one, which doesn't really matter because we can all put the greatest power on the denominator, like here. You can simply just put it here. Okay, now, as you can see, the greatest power of this one is going to be 4, right? And this one going to be 3, this one going to be 2, this one going to be 1. And as you cancel from the number here, 4, 4, 3, here will be 1 left. And you cancel, cancel, cancel. And this one will be 0, this one will be 0. This one will be 1 like here. And 0, 0, 0. Here will be 1 plus 0, 0, 0, 0, which will be 1 over 3. That is less than 1. This means this infinity series will converge.